Zinc phosphating process has an unwanted byproduct called the phosphating sludge. Now, handling this sludge involves costs. In this video, let's examine what those costs are. The main reason why there is excessive sludge built up in the zinc phosphate process is mainly because the phosphating bath that is designed for this pre-treatment process, the designers use smaller volumes of these tanks. The main reason for using smaller volumes is that the entire bath needs to be at an elevated temperature. The entire bath needs to be heated for the process to be effective. Now, if the entire tank volume is low, it will require lesser heating or the fuel cost will go down. In a way, to keep the operating costs low, the tanks or the phosphating baths are of smaller volumes. But the side effect of this is that as your production volumes increase, the sludge buildup increases proportionally, and because of these small tanks, the level of sludge inside the tank is very high or gets quite filled up very fast. Other effect of this sludge buildup is that the more the sludge that is accumulated in this bath, the less effective the entire process is. Hence, continuously removing this sludge is very important. Otherwise, the sludge that gets settled at the bottom, it just starts getting very hard, and eventually when someone has to remove it after a long time, it is a very time consuming process and quite dangerous as well. Now let us understand what I have observed during in the industry, the sludge removal process is. Now these involves broadly 5 steps. These steps we can see where an ineffective or there is no effective sludge removal system in place. So one is the entire cleaning cycle will have to be done when the production cycle is stopped. The entire phosphate bath will have to be pumped out along with the sludge, and then you'll have to store this entire bath, sludgy bath, somewhere, and then remove the top layer of fluid or the phosphoric bath and discard it in your ETPs, and whatever sludge that remains at the bottom, that will have to be discarded or you'll have to pay to discard that sludge. Third step is to refill the phosphate bath with a fresh solution. Fourth is raising the temperature of this bath again to the desired, generally it is done at 55 to 60 degrees centigrade, and then restarting the entire process. Now the entire time duration for this coating cycle or this cleaning cycle, there is no defined time limit for this, but as you can see, it is going to be quite a time consuming process. I have seen at certain locations where people are employed to go inside the tank and clean the sludge manually. So this is not only hazardous for the individual who goes inside the tank, because we are dealing with chemicals here, but a manual process is generally, we should avoid at least such non-value added steps to be done manually. Now let us see the costs that are involved in this entire cleaning process. One is the production loss because of stopping the entire coating cycle for such a long time. Second is the cost involved in discarding the used chemicals. Third is the water cost in refilling the bath. Fourth is the chemical cost for making the fresh bath. And fifth is the fuel or electricity cost for heating the entire bath to the desired temperature again. I sincerely hope you learned something new about the zinc phosphating process today. If you would like to know more about this process, please mention it in the comments below. And if you like videos like this, please subscribe to our channel, Think Filter. Thank you.